A standing wave can form when two waves of the same amplitude and frequency are moving in opposite directions. In this animation, you can see that the red wave is moving to the right, the blue to the left, and the black dots represent the sum of the two waves together. You'll notice as this progresses that the black wave just seems to be oscillating up and down, not moving side to side. And there's also regions called nodes where there's no oscillations happening at all. It might surprise you to think about how often a standing wave pattern happens, given that you have to have the same frequency and amplitude for it to work. But any wave reflecting off of a surface can form this because the incoming and the outgoing waves can interact with each other, making the standing wave pattern. The key detail is that not every frequency will work. Only those frequencies in which the nodes appear at the two reflection points will there be a standing wave. So the fundamental frequency is where you have the nodes happening only at the two ends. But you can double that frequency or triple it or multiply it by any integer n, and you'll get nodes happening in the middle. But no other frequencies will work. And here's a demo of that in the lab. That white box is a speaker that's sending a wave down to the end and reflecting it back. With the proper tuning, I can get a large response. And if I double that frequency, I get a node in the middle, and where I can triple it even. And this is how all musical instruments work. When you strum a guitar or you play the piano, the fundamental and all the higher harmonics are simultaneously created. All other wavelengths are damped out. And this gives the sound a characteristic note. Thanks for watching.